Imagine waking up tomorrow morning, but you only weigh a third of what you do right now. You look out a window to see a hazy, butterscotch-colored sky, and you realize you are 140 million miles away from Earth. Welcome to Mars in the year 2050. The sprawling glass domes of science fiction are nowhere to be found. Relying on glass here would lead to a swift death from extreme freezing temperatures and the constant barrage of lethal cosmic radiation. To stay alive, the first Mars cities were built downward. Residents live in highly pressurized, claustrophobic bunkers, shielded by meters of Martian regolith, the loose, rocky soil that serves as the colony's primary defense against the vacuum. Construction was completed long before any humans arrived. Autonomous robots spent years drilling, 3D printing the foundations, and sealing the infrastructure, preparing a pressurized environment where biological life could actually persist. A first morning on Mars requires a total, uncompromising surrender to the logic of life support engineering. A normal Tuesday begins inside a cramped, utilitarian living module, where every square inch of physical space is a calculated necessity. This cross-section shows the colony's severe water bottleneck. Automated systems extract subsurface ice, processing it into liquid. Because supply is finite, a ruthless closed-loop cycle operates. Every milliliter of moisture, from workers' sweat to breath vapor, is filtered and processed back into the drinking supply. Breakfast is equally industrial. With traditional soil farming being impossible, the colony relies on hydroponic greens grown in nutrient-rich water baths rather than earth. These indoor farms place a massive, continuous drain on the colony's energy grid. Since Martian sunlight is too weak for high-yield agriculture, the crops require high-intensity artificial lighting powered by nuclear reactors and surface solar farms. On Mars, satisfying basic human biology is a high-stakes industrial operation that must be maintained every hour of every day. The workday begins with a commute through protected, artificially lit corridors. The environment is a constant hum of mechanical air scrubbers and circulating fans. Stepping outside the habitat involves hours of safety protocols. Workers must seal themselves in heavy, pressurized suits and undergo multiple airlock cycles before they ever touch the Martian surface. Movement across the surface is restricted to armored, pressurized rovers. These vehicles crawl methodically over the rocky terrain, transporting personnel and supplies alongside autonomous cargo haulers in a slow-motion logistics network. Beyond physical dangers lies a psychological barrier. A radio signal takes 20 minutes to cross the 140 million-mile gap to Earth. A text message won't see a reply for at least 40 minutes. Every interaction is defined by this lag, creating a profound detachment from humanity. These laws of physics create a wall of isolation that no technology can fix, leaving Martian residents fundamentally disconnected from the real-time rhythm of life on Earth. Seen from the perspective of an individual worker, the 2050 colony is a place of endless maintenance and restricted movement. The gritty reality of this existence bears little resemblance to the polished, futuristic visions of the past. It is a life lived in the margins, dominated by the constant threat of equipment failure or resource depletion. Every hour is scheduled, every calorie is accounted for, and every breath is recycled through a machine. We have to ask why humanity would choose to endure such an agonizingly restrictive existence. Every day that the air scrubbers run and the hydroponic labs produce food is a day that our species exists independently of Earth's biological systems. By 2050, this dark, high-pressure industrial outpost has become a permanent fixture of the solar system, the first self-sustaining foothold for humanity in the deep silence of the cosmos.